Today, we're going to start Module 10, which is on circles. Today's lesson is 10.1 on circles and circumference. Okay, so we're going to work on applying formulas for circumference of a circle. We're also going to look at the line segments that are created inside a circle and how we define them and how to find some of those values. Okay, so the first thing we're going to do is look at the circle itself and how we name things correctly and some terminology and notation. All right, so the first thing to define is a circle is defined as the set of all points in a plane that are the same distance from a given point. That's called the center. So in this particular drawing, we would call this circle C, and that's the notation for it. They draw a circle and put a point in the middle to show there's a center, and then whatever that center point is what we attach to it. So circle C is what's shown over here. Okay, by the definition, interestingly enough, if you think of this as being a nail pounded into a board at point C, we stretch a string out to point F. If we put a pencil, let's say, in this string and we hold it tight and move it around, rotate it around point C, you're going to create a perfect circle because that's actually the definition. It's the point of the pencil is defining all these points that are an equal distance from this center that we said is C. So that's how we define a circle. All right, a couple of other things. First of all, a radius. The plural for radius is radii. These are line segments that join the center of the circle to a point on the circle, and they are written as line segments. So in our particular drawing here, we have three. CD, CF, CE are all radii in this circle. Again, radius has one endpoint at the center, the other endpoint on the circle itself. Even though this line goes all the way across, we have a name for it, we can still look at it as radius CE and radius CD in that circumstance. The next thing is a chord. And a chord is defined as a line segment whose endpoints are on the circle. So this is a chord AB. A to B is a chord, its endpoints are on the circle. And DE is also a chord because its endpoints are also on the circle. So those two are chords, and then we get a diameter. Now, a diameter is a chord. So by saying a diameter is a chord, that means that a diameter has to fit the definition of a chord as well. So a diameter is a line segment with endpoints on the circle that passes through the center of the circle. So in our case here, DE is a diameter. Now what a diameter does specifically is it cuts the circle in half. So these two endpoints, D and E, as we draw our line to connect DE, this chord, it passes through the center C, that's going to cut the circle into two equal pieces or two equal parts. A couple other little things. Within a circle, every radii is congruent and every diameter is congruent. So all radii in a circle are the same length. Any diameter we draw in this circle will be the same length. A diameter, because of how it's made up, especially, we look at DE here, a diameter is equal to the radius doubled. We just said CE and CD are both radii. DE is a diameter. Obviously, DE is made up of these two radii. So if you double a radius, you will get the length of a diameter. And then lastly, the words diameter and radius are twofold. Number one, they describe lengths. So, we can give a number for this radius length. And also they describe the segment itself. So you got radius CF, and we can also say the radius of the circle is 3 inches or whatever we want it to be. So it can describe a length as well as a segment. So there's the basic makeup of the interior segments of a circle. Okay. So one question you'll get tonight is they'll give you a drawing like this and ask you just to identify the center of the circle, the radius, chord, diameter, and so forth. So in this case, name the circle. How do we name the circle? We do it by its center point. So the center of this circle is X, so we would call this circle X. Name the radius or a radius. So what we're going to do is name every radii that we see. I guess if it just said name a radius, it probably should say A rather than the. You can only need to pick out one of them. But in this case, there are, X to Z is a radius, X to V is a radius, X to U is a radius, and also X to T. I didn't list that one, but X to T would be as well. All right, because we know X is the center, any point or any segment that goes from the center to a point on the circle is a radii. So there's actually 4 there to choose from. Okay, next thing it says is name a chord. We have 2 choices. RS is a chord and ZT is a chord. Okay, both of those are line segments who has endpoints on the circles. And then lastly, name a diameter. Well, diameter would be Z to T. A diameter has to be a chord, number 1, endpoints on the circle. Second of all, it's got to pass through the center. So the diameter would be ZT, and that's the only choice in this case. Okay, another question you're going to get or concept is to, given a radius or a diameter, find the other. So we know the relationship between radius and diameter is that if we double a radius, we get the length of a diameter. And also, if I'm given the diameter, I divide that by 2, I'm going to get the length of the radius. Okay, so they're asking to use that relationship. So if TU in this drawing, if TU is 14 feet, the distance from T to U is 14 feet. What's the radius of the circle Q? Well, looking at it, T to U is a diameter. It's a chord that passes through the center. Okay, so we know the radius of a circle is half of the diameter. It takes 2 radii to make a diameter, so the diameter divided by 2 is a radius. In our case, our diameter is 14, so we know half of 14 is 7. So the radius of this circle is 7 feet. Now remember, we said all radii are equal. So Q to T is 7 feet, Q to V is 7 feet, Q to R, they're all 7 feet. Second question now tells us the distance from L to M is 11 inches. We want to find the diameter of circle L. Well, JK is a diameter. Okay, LM, they're saying is 11 inches. So you could look at it this way. LM is 11 inches. Every radii is congruent. So L to J is 11 inches and L to K is 11 inches. Okay, I just kind of did it this way. A radius is equal to half the diameter, or a diameter divided by 2. Okay, 11 is the radius. That equals a diameter divided by 2. Multiply each side by 2 and you get 22 inches. This is kind of a long drawn out way of doing it. I would assume you understand that JL is 11, LK is 11. That's a total of 22 inches for that diameter. So you'll get some questions that are asking you the relationship between a radius and a diameter. All right, the circumference formula is next. The title is Circles and Circumference. So we're going to start finding circumference. So definition, circumference is basically the distance around a circle. Okay, circumference is to circles as perimeter is to polygons. Perimeter is the sum of the lengths of the outsides of a shape. Well, that's the distance around the shape. Circles are round, so you can't just add up segments. You have to calculate this one. All right, so if a circle has a diameter d or a radius r, then we can find the circumference by taking the diameter times pi, or we can do twice the radius times pi. Since 2 times the radius is a diameter, we wind up with 2 different equations here. So circumference equals pi times d, or we can say circumference equals 2 pi r. So we have 2 different equations we can use. Which one do you choose? Well, it depends on which one you're given. If you're given a diameter of the circle, then I would use this one. If you're given the radius of the circle, then I would use this one. So you just have a little option there based on what information you're given. Okay, and by the way, this whole pi symbol, okay, this pi symbol is created or was created when they studied circles initially. Okay, and basically what happens is if you take any circle's circumference, the distance all the way around the circle, and you divide it by its diameter, the distance across the circle, you always get the same answer, 3.1415 dot dot dot. Okay, that's pi. So pi is actually the answer to any circle's circumference divided by its own diameter. I don't care how big the circle is or how small the circle is. If you take the circle's circumference and divide it by its diameter, you get the same answer every time, which is this pi value. And that's called an irrational number, or pi is an irrational number because it never ends. It doesn't repeat in any kind of a pattern. It just goes on and on and on and on forever. Okay, so a little bit about pi there. You have a pi symbol on your calculator that you can use. So, when we do some calculating with pi, you're going to want to use the pi key. I will tell you this. 3.14 is an approximation we use for pi, but a pi symbol on the calculator uses all of the number pi. 3.14 is just part of the number for pi. So you may get slightly different answers whether you use 3.14 or the pi key. Let's use the pi key. All right, here's an example of finding circumference. So traffic circles, also known as roundabouts, are circular roadways that reflow traffic in one direction. So this is what a roundabout looks like. So you enter the roundabout, everybody's going to be going clockwise, okay, and then you get off at whatever exit you want. So it replaces stop signs, stop lights, and so forth. So a car enters the traffic circle and it's 18 meters. So let's say we're looking at this car and it's 18 meters from the center of the circle, center of the island. If it drives all the way around back to its original position, what's the circumference of the car's path? How far is it driven? Okay, well, it's basically a circumference question. All right, they're telling us the radius is 18 meters because that's the distance from the car to the center. So that's the center to a point on the circle. So the radius is 18. We know to find the circumference, we can use 2 pi r as a formula. I'm using 2 pi r because they give me radius. So plugging in what I know, the radius is 18. I'm going to replace r with 18. Now, one answer we can get is 36 pi feet. This is exact, okay, because pi is an irrational number. As soon as I put a number in place of pi, now I'm going to have to round it, or I'm going to have to approximate pi, which means now it's not going to be exact. This is exact. So they may ask you to leave your answers in terms of pi, or don't substitute for pi. That means this is the answer they want. It's exact. Okay. If you are asked to round it or approximate it, then you do take 36 times and then hit the pi key in your calculator, hit equals, and round. In this case, there's 10th, and we get 113.1 feet. Okay. Obviously, it depends upon what you're doing with the answer. If you're actually trying to figure it out and you need to get a number approximation, then you want to do this part of it. If you're going to use this information and keep working in a problem with it, then you're probably going to want to leave it exact and then deal with it later. Okay. So there's a little bit about finding circumference. All right. Find diameter and radius. So if we're given a circumference of a circle, how can we find the diameter of the radius? All right, so in this case, they want us to find diameter and radius, and this circle has a circumference of 77.8 centimeters. So what do we know? We know circumference is 77.8. We're trying to find diameter and radius. I'm going to find diameter first, so I'm going to use my formula that is C equals pi d. I'm going to plug 77.8 in place of circumference. I'm going to divide each side by diameter, or excuse me, by pi to isolate diameter, and we get 77.8 divided by pi equals diameter. So at this point, I would take out the calculator, go 77.8 divided by, hit the pi key, hit equals, and we get diameter is about 24.76 centimeters. So they ask us to do two things, find diameter, find radius. We found the first one. Let's go find the second. Diameter equals 2r. We know that the diameter of a circle is equal to 2 times any radius. So we now know the diameter is 24.76. That would have to equal twice the radius. Divide each side by 2. Our radius is 12.38. So given the circumference, you can find diameter and radius. It doesn't matter which one you find first. You use the first to find the second, however. All right, so that's a little bit of those questions. And then finally, we're going to apply the concept of circumference and look at how we can use that to find some solutions. So let's take a look at this one. All right, Lamar races his bicycle for 336 feet. The wheel of his bicycle turns 42 times as the bicycle travels this distance. What is the diameter of the wheel? All right, now it's saying use 3.14 for pi. So when we go to approximate, we're going to use 3.14 for pi. We're going to round our final answer to the nearest tenth, and we're not going to round until we get to the final answer. That's what it means by do not round to intermediate steps. All right, the first thing we have to understand is we got to find the circumference of the wheel. And the idea here is if you have a wheel, okay, and you roll it, the distance that it moves in one revolution is the circumference of the circle. It's just like kind of unwinding the circle, okay? So every revolution of the tire, along the ground is a distance of circumference. Okay, so if it turns 42 times in 336 feet, then 336 divided by 42 has to be the circumference of that wheel, the distance all the way around the wheel. And that's about 8 feet. So we're saying that the distance, the circumference of the circle is 8 feet. Every revolution of the circle. So if you mark the bottom of the tire and roll it till you get to that mark again, you've gone 8 feet. So I know circumference is 8 feet. So now we're kind of back to the last question. I know circumference is 8. I want to find diameter. Okay. They asked me to find the diameter of the wheel. I'm going to divide each side by pi. We're going to use 3.14 for pi. So 8 divided by 3.14, round to the nearest tenth, is about 2.5 feet. It's a very common question with circumference is a wheel turning, because a wheel turning is the revolution of the outside is actually the circumference of the circle. So you're going to get some questions along this lines tonight as well. So a pretty straightforward section here on the basic makeup of a circle, applications, or finding circumference, and a couple of basic applications thereof. Okay, so I'll let you get going on your homework. Guys, keep working. We don't have that much longer this school year. Let's make sure we finish strong.